Hi, my name is Patricia and I'm going to talk about macrophages. Macrophages come from the common myeloid progenitor, and so they are part of the innate immune system. They are found as monocytes in the blood and become macrophages once in the tissue, as you can see in the diagram right here. They can actually be found as resident macrophages in several tissues too. They have a long life, several days, and their main functions are phagocytosis, cytokine production, and antigen presentation. And this is how they will look under a microscope. So, to explain how they work, I'm going to use a bacterial infection as an example. First, bacterial panels are recognized by PRRs, so they become activated and promote the release of histamine and cytokines like TNF or IL-1. And this will help to the recruitment of other immune cells to the infected tissue. Well, second, PRR's activation also enhances phagocytosis. So a phagosome is formed in the macrophagy, which is basically a vacuole containing the bacterium in this case. Later, the phagosome is fused with a lysosome that contains enzymes, forming a phagolysosome, where bacterium is digested. And finally, antigens from digested bacterium are presented to naive T cells through MHC complexes, starting this way the adaptive response. So they will be like the link between the innate response and the adaptive response. Finally, one example of a disease would be the macrophage activation syndrome, which is a severe complication with up to 30% of mortality in many rheumatic diseases, but most frequently in juvenile idiopathic arthritis. And what happens here basically is an uncontrolled activation of macrophages and T cells and an increased release of cytokines that produces systemic inflammation. And well, the pathogenic mechanism that is still unclear, but it's usually associated with a decrease of the number of natural killer cells. And well, that will be my presentation. I hope everything is clear, and thank you for listening.